Welcome back, everybody. We are continuing graphing parabolas, and today we're going to focus on vertex form. If you would pause the video and jot this stuff down for your vocab. And I'm going to add that H and K are your vertex. If it is x plus h squared, then your vertex would be a negative because it's the opposite. The other thing that I'd like for us to write down here is that this plus or minus h is now a shift left or right of our graph for transformations. So let's say that you had x minus 2 squared plus 4. Remember, it's opposites inside with x. So this would be moving right 2 units and up 4 units. If we had x plus 7 squared plus 9, then again, opposites inside, that's going to be a left 7 units, up 9 units. If we had x plus 5 squared minus 2, this plus 5 would be left 5 units and down 2 units. So let's start with finding the vertex and axis of symmetry. I'm going to switch to purple here. The only thing I'm looking for is the stuff right after x and then on the outside at the end. Remembering that for our vertex, it's always the opposite of whatever's in here. So if that's x minus 7, then our vertex is positive 7. And then negative 4, its face value on the outside. And because our axis of symmetry is always the x value of the vertex, then it's also x is equal to 7. For our next one, we have our h and our k. So for our vertex, remember it's opposite of what's inside the parentheses. That's going to be a negative 11 and then a positive 19. Our axis of symmetry, because it's always the exact value of the vertex, would be x equals negative 11. And for this last one, we have a positive 32 inside and a negative 74 outside. Remember, this right here is always opposite, so it'll be a negative 32 for our vertex and negative 74. And then our axis of symmetry will be x is equal to the x value of our vertex, which is negative 32. Pause the video and grab your calculator if you don't already have it with you. Finding the y-intercept. So the last part that I want to practice before we get going today is finding the y-intercept. Remember, the y-intercept is going to be 0 and then the y value. Because of that, to find the y-intercept, we plug 0 in for x and evaluate the expression. Remember, evaluate means to find the answer. So, for letter D, we would have y is equal to 3 times 0 minus 7 squared minus 4. You can type that all into your calculator the way that you see it. Or we can work step by step. Start with 0 minus 7 is negative 7. Negative 7 squared is positive 49. And 3 times 49 minus 4 is 143. So 0, 143 would be the y-intercept of that quadratic. Letter B. y is equal to negative 2 times 0 plus 11 squared plus 19. We have negative 2 times 11 squared plus 19. 11 squared is 121. And so negative 2 times 121 plus 19 is negative 223. 0, negative 223 then is our y-intercept. And for this last one, we have 2/3 times 0 plus 32 squared minus 74. 0 plus 32 is 32. 32 squared times 2/3 minus 74 in our calculators is going to be a decimal, so we'll round that to 0.7, and we'll estimate our y-intercept to be negative 608.7. All right, graphing. So we have a half times x minus 4 squared. Now there's nothing on the right side. We didn't add anything there. If you'd like to, you can write a plus 0. Remember, the 1/2 is your a, the minus 4 is your h, and that plus 0 is your k. That means our vertex is at positive 4, 0. Our axis of symmetry is at x is equal to 4. Our y-intercept, we would do 1/2 times 0 minus 4 squared. I'll plug that into my calculator, or you can do the math by hand, and you end up with a y-intercept at positive 8. And so I'm going to put my vertex here in the middle. Then I'm also going to put my y-intercept. Remember, we can use our axis of symmetry like we did back in section 8.3 to help us with a third point. If I plot our 4, 0, it's right here, plot the 0, 8, which is up here, and draw in my axis of symmetry here, then we can use the fact that if we have 0, 8, 1, 2, 3, 4 to the left of my axis of symmetry, then I also have to have that same point 4 to the right of my axis of symmetry. And that's based just on the fact of the definition of an axis of symmetry. And so our other point that we're using is 8, 8. And I can draw my parabola. Here. How many real zeros do we have? Well, remember, real zeros are what's touching the x-axis. And we have our dot right there, which is our vertex. So there's one real 0. Our parabola is opening up. Our domain is always negative infinity to infinity. Our range, y, is greater than or equal to, the y value of our vertex is 0. And our transformation. So we do have an a. That 1/2 is a vertical shrink. And then remember, we're asked to compare this to our parent function. And so you don't need to draw this in, but I'm going to make a quick sketch of our parent function right here. And notice that this traveled to the right 1, 2, 3, 4 spaces. And so this shifted right 4 units, which is what we talked about also in the very beginning there, that whatever's inside with X is going to tell us that we're going left or right. We didn't go anywhere up or down because of the 0 on the outside. Let's try this next one. So this negative is going to flip our graph. This plus 2 is our H. We don't have anything over on this side, so I'm going to add a plus 0 for our K. Remember, our vertex is the opposite of whatever this is, so if that's a plus 2, then our vertex is going to be at -2, 0. That makes our axis of symmetry x equals -2. For our y-intercept, we're plugging in 0 for x, so we have -0 plus 2 squared. And so when we do that math, we get 0, -4 for our y-intercept. I'm going to go ahead and put in our vertex and our y-intercept and plot those on our graph. We have -2, 0 is here. 0, -4 is here. I'm going to draw in our axis of symmetry to help us with another point. Again, if this y-intercept is 2 to the right of our axis of symmetry, I can go 2 to the left of our axis of symmetry and have that same point there, which is at -4, -4. And now we can draw our parabola. This parabola is opening down. Real zeros, remember, are the exact same as x-intercepts. Here is the x-axis, and this point is the only place it's touching, so we have 1 real 0. Our domain, again, is still -infinity to infinity because of the arrows we have at the end there. And then our range, we have y. We're going down, so that's less than or equal to. And the y value of our vertex is 0. Our transformations. So we talked about this negative in the front as a flip. Remember, that's really called an x-axis reflection. And then the plus 2 took our parent function. Remember, our parent function starts at 0, 0, and it went to the left 2. So left 2 units. All right. In this example, we have this a value in front, h, and k. Remember, our vertex is hk, and it's the opposite of this sign, so it's going to be a -2, +3. Makes our axis of symmetry x equals -2. The y-intercept, we plug in 0 for x, so -2 times 0 plus 2 squared plus 3. We do that math either in our calculators or in our heads, and we get 0, -5. So I'm going to plug my vertex in to my table and my y-intercept. Plot my vertex. -2, 3 is here. 0, -5 is here. I'm going to draw in my axis of symmetry. This y-intercept is 2 to the right of my axis of symmetry. So 2 to the left is another point, and that's at 4, -5. Or sorry, -4, -5. So -4, -5. And now I can draw my parabola. This graph is opening down. Real zeros, again, are the places where our graph touches the x-axis. So my x-axis is this one, and I'm touching the x-axis here and here. That means there are 2 real zeros. Domain, -infinity to infinity. Range, y, we're opening down, so that's less than or equal to. And the y value of our vertex is 3. Let's talk about our transformations. Let's start with our A. So the negative is its own thing, which is our x-axis reflection. The 2 is a vertical stretch. The graph is getting narrower, stretching towards y. And then if I mark on here my original vertex, we went left 2 and up 3. Left 2, up 3 from 0, 0. So left 2 units, up 3 units. And that's where we're going to pause for today. We will take care of that last example in class together tomorrow. Thanks so much for joining me. Have a great night.